on towards cost effect. Welcome everyone. Welcome to today's lunchtime talk on towards cost-effective neighborhood CAQMS or continuous air quality monitoring systems with Associate Professor Dr. Shahrul Nadzir, who just came in from a TV3 interview early in the morning. And so now he's at the to another lecturer has generously offered the premise before he rushes off to MOSTI for another discussion. So thank you, Dr. Shahrul, for giving us the time to share with us your experience and what you feel how air quality in the neighborhood should be like in the future. And we hope that everyone will also benefit from it. There will be a recording that we can share, but hope you can stay tuned throughout the whole session, and maybe we'll have just a short photo session afterwards to commemorate the event. I'd like to especially mention also that Dr. Shahrul will be heading for US because he is the 2023 recipient of the Fulbright scholarship from the USA. So Tanya, not easy to get it. So I'm proud as a fellow Malaysian that you have been chosen to represent Malaysia in this field. We need a lot of attention paid to the environment and to take care of our Malaysian natural resources. Okay, this talk is proudly brought to you by Soxnox Asia, EPG International, and Perunding Utama. We are sibling companies, and let me just share a screen on a brief company profile before we start. Yeah, Tanya, doctor, someone mentioned there. Congratulations. Yeah, thank you. Let me start sharing. All right, just a brief background on the three companies. Okay. Okay, I hope everyone can see. Yeah, as mentioned, we have three companies organizing this event, which are Soxnox Asia, EPG International, which stands for Environmental Professionals Group, and Perunding Utama Senjuan Berhad. What we do, we specialize in different areas. So Soxnox or SNA specializes in air quality and odor, and environmental noise and vibration. Then we have EPG International on the right. We specialize in capacity building and quantitative risk assessment. And lastly, we have PUSB that specializes in sustainability in the ESG environment. And here is the team of people. It's a modest team, but a very hardworking team, headed by TS Tan Po An, who is the principal consultant and the founder of all three companies. So on the white bar, you will see the socks, his right hand, left hand people. And then the pink bar, we have Soxnox Asia. The green one is EPG International. And then the last one is Perunding Utama. Yeah, I'm Sharon. Sorry, didn't introduce myself. I'm Sharon. So I'm the person in EPG International along with Shahida and Malvin. Yeah, quite a young team, vibrant team. All right, so Soxnox Asia was established in July 2009. It provides specialized services in the area of air quality and odor and environmental noise and vibration management for both local and international customers. And for EPG International, it's quite young. It's still a toddler, established in 2018. It stands for Environmental Professionals Group. And it carries out events such as training, workshop, environmental talks, seminars, such as this one today, as part of our building capacity upskilling mission that we want to especially help grow the environmental professionals community. All right, we also offer QRA risk assessment for assessment of hazards in environmental related studies. And then we have Perunding Utama, which was started in 2021. It's been reincorporated. PUSB is a company that was established and then it stopped, and now we reincorporated it. So it is addressing the environment in the whole ESG, or what you call environmental, social, and governance pillars. And PUSB offers services related to preliminary site assessment for new industrial projects, particularly within Malaysia, with the intention of incorporating sustainability mindsets as part of the company's planning. And here we have the specialized services that are offered: air quality and odor, environmental noise and vibration, quantitative risk assessment, capacity building, sustainability, preliminary site assessment, subject matter or expert witness, and also guidelines or legislations which are environment related. Anything, if you're not clear, you're most welcome to contact me. Okay, hold on. We still have people coming in. All right, so I will stop sharing and I will hand you over. I will do a brief introduction of Dr. Shahrul before we start. Let me just stop sharing this particular. Okay. There's still some more people waiting. Okay, just a short introduction of Dr. Shahrul. Okay, Associate Professor Dr. Shahrul hails from Malaysia, and he is the senior lecturer at the School of Environmental Science and Natural Resources, Faculty of Science and Technology, University Kebangsaan Malaysia since November of 2008. Previously, he was a postdoctoral researcher at the National Antarctic Research Centre, University of Malaya, from March 2013 to June 2013, before joining UKM. He specializes in environmental science and atmospheric chemistry. His current research interests are climate change, atmospheric chemistry, laboratory instrumentation and analysis, and air quality. In 2015, the Vice Chancellor of UKM has appointed him as the head of Center for Tropical and Climate Change, or ICLIM, at the Institute of Climate Change under Professor Dr. Muhammad Nizam Said. Currently, Dr. Shahrul is still the head and at second term period until September 2019. Oh, that's, yeah. Maybe Dr. Shahrul can update us a little bit. Dr. Shahrul also obtained his BSc, Bachelor of Science in Environmental Chemistry from UKM in 2005, and his Master's in Process Engineering and Plant Design in 2008 from Brandenburg Technical University of Cottbus, Germany. He obtained his PhD from under Prime Minister Initiative 2 in collaboration with the University of Cambridge, United Kingdom. So yeah, that's quite a lot of credentials. So, and then he will add Fulbright to his another feather on the cap. So without further ado, I will hand you over to Dr. Shahrul for the next session, the proper talk. At the end of it, there will be Q&A, where you are most welcome to either voice or you can type in the chat box the questions and I will read it out. and your concerns that some of you posted to me during the registration. I will also share it. Thank you, and the floor is yours, Dr. Shahrul. Thank you.
Yeah, Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon. First of all, I would like to thanks to Mr. Tan and his team especially EPG International, Soxnox Neighbourhood, for inviting me. My first webinar with the companies Okay, I also quite nervous. I can see Puan Nolin also here, Dato' Alimah, all the Taiko and Sipu from DOE. I just for today, I just representing not myself, representing my rest of my team who has been assisting me on this topic, especially on the low cost census for the past since 2016. And also especially UKM, my permanent post is that have been supporting and funded me and the rest of the team since back in 2017. So we started the project from 2016, but we get funding from 2017. And then also, of course, Meranti. And I just want to mention that this product has been won Malaysia Commercialization Year MCY back in 2019, and also we received award from Malaysian APICTA program, Asian Pacific ICT Alliance back in 2020 during lockdown COVID-19. Okay, I am from UKM, and of course, thank you so much, Ms. Sharon, for the introduction. First of all, I would like just to introduce our team. Basically, to work in any kind of environment, you cannot work silo. You need to have a friendship team, not just inside but also external collaborators. So basically, this is just a small team. We came from many various of background, from engineer, scientists, big data analysis, and also public health. I think most of the DOE or most of you know Prof. Mazura Sani. She has been used our census data to do a health risk assessment and many more. So we are not just talking about the hardware, but we also, how can we value from a census that can give at least accurate and precise data. So this is just for basic introduction about community and authorities. I think as Ms. Sharon mentioned, that I'm one of the recipient for Fulbright exchange scholar that I will be placing at University of Utah. So during my Fulbright, basically, there's no more developing sensor or whatever, but I will be there how to use this kind of technology to communicate with agencies and community. So that is the main reason I will be there for about 6 months, and entirely sponsored by US government. So this is basically how we can use to engage between community and authorities. So there is one popular term known as citizen science. I think maybe you can Google what is citizen science. Basically, citizen science, one of the concepts that have been used in the US, in the Europe, to engage or to communicate between, to solve a problem by engaging community and authorities. In the term of citizen science, in our concept, is basically in air quality subject. So how can we trust sensor or so-called low argument, what actually you define by low cost. So basically, I would like to use cost efficient instead of low-cost sensors. So how can we trust these cheap sensors, and how can we use this data, and how can we make use of the data, and what is the final output between this engagement? So this is basically how we would like to. Of course I would like to learn more for Malaysian future in collaboration with agencies like DOE and so on. Okay, basically when we talk about cost-efficient sensors, basically in the US, I just frankly speaking, I just want to say that there's nothing strong recommended by any agencies in the world. For example, last year when I was invited, I was sponsored by US EPA to be in North Carolina, where I attended a conference on low-cost sensors. How can we make sense of sensors? So even US EPA, the one that organized that and also funded the entire workshop or conference, but there are still nothing a strong guideline that recommended by US EPA. But at current, we like all the scientists from the US, especially in collaboration with US EPA, they are still developing a protocol, guidelines about these low-cost sensors, because one advantage of these low-cost sensors is that it can be deployed at many areas, so that it can represent spatial and temporal distribution of air quality. Because, for example, you cannot say Putrajaya similar to Bangi, because even though UKM Bangi and Putrajaya are very close, about 10 minutes drive, 15 minutes drive, but the type of sources of the pollutants are different. So instead of placing expensive equipment, we can use this tool as a representative or a complementary device to support reference analyzers, for example. So this is basically what I can give some update on US EPA side about this cost efficient sensor. So this is our technology called Airbox Sense. It has been established back in 2017, and I will explain to you how we do the quality control and so on. Okay. So basically, low-cost sensors is not as a plug-and-play tools. Okay, so our strength at UKM is developing the software and how you maintain so that the sensors give almost quite accurate data as compared to the reference analyzer. So this is our job at UKM. We try always to emphasize the calibration and validation method to make sure that we will not give a false alarm to the public communities. So I will go through on that technical aspect after this, but this is basically how we can assist in terms of SDG goals. So from good health and well-being, sustainable city and communities, and climate action. This is just, I think most of you already alert on our haze issue, and then back in our 2019 incident, I think I still remember with Puan Nolin, we together part of the task force appointed from ex MESTEC minister. So we can see how important to monitor air quality by real-time monitoring, and how we can send information to the agencies and communities. So this is one thing that I learned from Pasir Gudang incident last time. If we can have use technologies such as now people keep saying about IoT for IR. So this is one of the opportunity for us to use this technology to help the community and the agencies. without giving a false information. But this kind of platform are very, very useful to alert community and agencies related to air quality issue. Okay, this is the citizen science. In fact, in Japan, already conducted this. I still remember for the past 2 months ago, after Raya, I think RTM at Selamat Pagi Malaysia program, one lecturer from has been invited to talk about citizen science. I think this is citizen science that we are really supposed to apply in Malaysia, especially in the urban area and rural area. I will also share to you our first project with UNICEF using these air quality sensors as a part of citizen science in Petaling Jaya that managed by MBPJ and UNICEF. So we part of the technologies that provide this kind of sensors to monitor air quality for children and school. Okay, I just want to show you what even though during lockdown I cannot go out, but our sensors are out, okay, and still giving reading. So this is one thing that I can, while stressful at home, I download the data, and we managed to see how the reduction of certain gases or particulates during a lockdown situation. You can imagine during lockdown is kind of a big experiment to control the vehicle emission. So during the lockdown, we can see how the impact on vehicle emission reduction that can be seen by the sensor. So you can see the tremendous reduction, about 30% or less during MCO during the normal day in the context of PM 2.5. Basically, I'm not claiming that Malaysian is the first champion in these cost-efficient sensors for air quality, but basically we learn from developed countries such as in the UK. Back in during my PhD last time, we designed a portable gas chromatography to deploy in the deep forest to measure biogenic VOCs during that time. And then Prof. Talib from UKM, our mentor, we managed to secure a Newton grant from the UK government to work together with Prof. Rod Jones at that left-hand side picture. There's a Prof. Rod Jones, my ex-supervisor. And so we deploy, I think, in the collaboration with, of course, Prof. Dato' Azizan from University Malaya, we deploy more than 20 sensors in collaboration with DBKL in Kuala Lumpur. So this is the one of the longest project. I think it's almost 3 years, and how we can see these low-cost sensors can give some information regarding air quality distribution in Malaysia. So this is just our evolution of our airbox sense. Just want to share with you. Basically, the yellow shirt is my best student, who actually the brain behind our low-cost technology, called Dr. Kamal Maulana. He is Indonesian, by the way, so I can say this airbox sign is part Malaysian and part Indonesia. So this one kita serumpun kan. So this is what I can say about our sensors lah. Now Kamal is back in Jakarta. He's working with government agency to build also low-cost sensors for air quality purpose. So this is just our apps. Okay, we are not just assemble the sensor, design the new control electronics boards or something like that, but we also develop the software. So how we develop apps and dashboard for our users and our collaborators for various type of research project. So I think Puan Nolin and Dr. Alima probably know this kind of air quality station that also owned by Department of Environment, operated by PSTWs or Pakar Sino Transporter Sdn Bhd. I think, if I'm not mistaken, DOE currently have about 65 CAQMS, continuous air quality monitoring system, where they have well-established gas analyzers to monitor air pollutants across the states, right? So as I mentioned just now, to monitor air pollutants, we cannot depend on the one station, because it will not represent, even though it's near, location is near or something, because each pollutants emitted by different kind of sources. Okay, can be from vehicles, can be from industrial area, can be from open burning, and so on. And when we talk about air pollutants, there are a lot of major factors that we need to be alert on, especially the wind direction, wind speed, humidity, and temperature. So this kind of technique basically need to have knowledge so that we can identify where the sources came from, and we can do a lot of prediction and so on. So this CAQMS also relate to the usage of big data. You can imagine CAQMS monitor every hour. So you have hourly data, you have daily data, you have weekly data, and you have monthly, and also can be reached yearly data, and many more. So this big data is one of the major contribution to know deep on air quality distribution across Malaysia. But how you value that data, how you the end product of the data, what you can do with the data. Basically, there are a lot of opportunity using machine learning, using AI, and many statistical analysis to investigate more. So this kind of platform, basically, nowadays people talk about big data analysis. So you need to have a good expert in big data so that we can make more value of our air quality data set. We cannot become for the past a few years the same thing. We just do the reporting, we just plot yearly air quality time series. But nowadays we need to have a good approach so that the community can understand what actually the meaning behind this result. So this is what opportunity that we have a few expertise from mathematics department, from IT department, from engineering department, so that we can help each other for future air quality monitoring. I think I don't want to go too deep. As you know, this is the typical. There are many brands basically for gas and particulate analyzers. I think Puan Nolin and Alima know much more better than me. So this is basically our sensors can measure various type of gases. Even now we commercialize to Petronas. Petronas Research Sdn Bhd use our VOC sensors to monitor their lab emission. And MBPJ use our sensors I think since 2019, before COVID. So almost 3 years they are using our sensors, and we thank to MPJ lah, since for the past 2019 we don't face any problem with the sensors, as long as I said, as long we do the routine calibration, maintenance, and so on. So the advantage of as I said just now, about the use of IoT. So basically you can imagine this sensor is just like our mobile phone. So we store the data, like we store our friends' phone numbers. So that is like a concentration of data from air pollutant. So we store the data in SIM card, in SD card, sorry, and also in cloud. So where we can process automatically in cloud system to produce the air pollution index and other things that we can use. So basically, this is the advantage of using the cloud system where we can calculate. Instead of you go to the field site, take the data, and then back to the lab, and then bring USB stick and so on. But that is old-fashioned. So why not we use this IoT platform? And in fact, the government talk about 5Gs now, and this is opportunity, easiest way to deploy our sensors at remote region and so on, due to this kind of easy communication. So this is just a demo how in the US implemented these low-cost sensors to have a deep, high-resolution air quality data set by deploying so many sensors network, and using machine learning to do the analysis. So this is one thing. We don't have to use Excel sheet anymore, Microsoft Excel to plot the data, to download the data. But now we have such as like program like Python, MATLAB, and any other software that we can easily download, because you cannot simply plot data like 10 years data, 5 years data, since you have so many data. So this kind of software can assist you to ease your plot and analysis. So this is basically our design for MBPJ. We develop also the apps. So I just want to remind you that these apps only for API visualization to the users. We will not simply share our raw data to public, and so there's a lot of security that we need to be aware when we designing the mobile apps and dashboard. So this mobile apps basically is depending on the client, whether they want the apps just to monitor the API, or they just want to know the sensors are working. So basically all these apps will give you information on the running of the sensors, the API values and other proposals. If you can see at the bottom, if you press home, you will see the location in the context of mapping area. For example, we use Google Map to liaise with our app, so that if MBPJ press home, they will see 5 sensors that are working. If it's not working, so you will know that there's something wrong with the sensors. So this kind of basic apps can give more. And we also design, like at the bottom there, you can see news and info where, for example, like UNICEF project with Sekolah Menengah Kota Damansara, they can put their school activities in the news info to advertise or something like that. And if you press at each station, for example, if you press using your fingers at Bukit Gasing, and it will appear this health recommendation or precaution step. So if in moderate, what you're supposed to do, if dangerous or unhealthy, what you're supposed to do. So this one thing basically can help the public to manage their routine activities, even though in his situation. So this is basically our solution to our collaborators or our clients, where from the dashboard, it can help the admin of the, for example, in this case, MBPJ, they can download directly daily data or weekly data and so on. They don't have to use the old-fashioned. So this is one thing, the dashboard basically we design to retrieve the data and in the term of raw data. But the apps, we just visualize what a basic information such as API and so on. So this is how if we deploy at various type of areas, we can use machine learning, we can use atmospheric modeling to do forecasting and predicting and so on. So this is what actually I started to wanted to emphasize on the quality of the sensors. If you go, for example, if you go to Jalan Pasar, you can get like a smoke detector, the price of 15 ringgit, and then you have Arduino, you have Raspberry Pi, you assemble, and then you get the reading. But to do a school project like that for STEM education is very good. But if you want to work or collaborate with agencies in term of to get a good air quality monitoring, so this is one thing that characteristic of sensors that you need to balance with your requirement. So for me personally, I always emphasize the sensitivity of the sensors. As I said, in Jalan Pasar, maybe the sensors is only just for, I don't know, for to detect smoke, but to quantify it, you need to have a good sensitive of sensors. There are many brands basically. Okay, I just want to emphasize also that we at UKM we not produce the sensors, but we only assemble the sensor. What we design from our side is only the communication board in terms of our own microcontroller. So microcontroller basically such, I think, as you know, like Arduino or Raspberry Pi. So we have our own ARM, our microcontroller that designed by my student who are good in programming and electronics. So that basically the part that we patented for our product. We will not patent any sensors because the sensors basically we purchase from a good quality company. In our case, we use brand. I will show you later in next slide what kind of a brand that we use from UK. Because we don't want to go cheap, but the sensor is not sensitive at all, or it overlay with various type of pollutants and it give wrong information. So you need to have a sensitivity towards individual pollutants. So this is just application that we suggested for from our airbox sense. So basically, this is the elements of our airbox. So you have first, of course, you need the sensors. You need to have the power system. The power system basically related to the microcontrollers, GSM modules, and many more. As I said, to assemble the sensors, you need to have a good programming, a good engineer, so that it can process the sensors from voltage to produce air quality concentration. So how the voltage can be changed into concentration unit like ppb, ppm, and so on. So we use, of course, to transmit the data, we need to have Wi-Fi or GPRS or LoRa and many more. So of course, the enclosure need to be weatherproof and waterproof. So this is basically from the point just now how we assemble so that it can send the data to the cloud, process the data, and visualize it in the dashboard and apps. So this is so far our users. Okay, we have we do the basically we do the proof of concept first, the POC first, before we deploy it. So basically now we have more than 20 units that deploy, more than 20 units in Peninsular Malaysia, and we have a few units in Sabah and Sarawak. We also used by our collaborator, our project, for example, like in India, we received grant from Japan called iStick. So this ASEAN grant basically is to fund us to deploy air quality networks across India, Malaysia, Philippines, and Indonesia. So as I mentioned, cloud. So basically, cloud is to store the data, but at the same time, in our box, we also have SD card, so that if there is a internet connection problems, the data will be stored in the SD card. So this cloud, the brand that we use is called ThinkSpeak. So why we choose ThinkSpeak is because ThinkSpeak is one of the product by MATLAB. So I think most of you know MATLAB software, that statistical software or coding software that used to ease you to plot any big data. So ThinkSpeak is basically one of the cloud, the famous cloud. You have Amazon, you have and many more. There are many brands that you can choose, but in our we use ThinkSpeak. So ThinkSpeak, basically we can create many more one channel for one unit of sensors and many more, where you can download the data, you can store the data, and you can, in fact, you can see live graph of your time series of the air pollutants. Okay, now this is the part that I think we need to understand. So this is basically how we do before we do or develop our sensors. First, of course, from we need to do the case study. We need to find out which sensors are the best from the literature, studies, and many more. Then how we how we manage our team. How can we recruit a good engineer, a good quality control engineer, and many more, so that our hardware can be developed from ideas into the reality, and how we can implement calibration to make sure the sensors working well. So what is actually calibration? Maybe some of you know what is calibration. So maybe it's not really the same for calibration sensors. Okay. So this is basically the step that we are using until now. So this basic principle of application of cost-efficient sensors, from the design to laboratory test to the field test, and then sensor installation and how you maintain the sensors after the lifetime of the sensors expired. So this is basically our method to make sure our sensors can be somehow I'm not saying that can be precise, but somehow can at least reach the similar reading by reference analyzers. So this is the brand that we use. I never use. I started to use a few brand at the moment for a few gases for our sensors, but this is the common alpha sense. During my PhD, when I was in the UK, we used this kind of sensors from this brand. So alpha sense has been established since late 90s, 1990s, and there are many type of or detector or transducers. So if you see there, each transducers will detect different kind of pollutants. So that you can see from electrochemical, NDIRs, PID, photoionization detector, OPC, and metal oxide and pallister. So this is type sensor that been widely used in UK, in Australia, and many factories and agencies started to have their own sensors to monitor their specific gas by using alpha sense. So you can search alpha sense and you can see the technical data sheet. You can download how the calibration that they are conducted, that you can read through. For our case, normally we use electrochemical sensors. So that's the common air pollutants that measured by DOE, like NO2, ozone, CO, SO2, and we use optical particle counter for PM10, PM2.5, PM1, and black carbon. Since past 2 years, for the past 2021, after we worked together with Petronas, we use photoionization detector to measure VOC, And for your information, the PID can detect various type of VOC based on specific individual detection. From benzene, toluene, xylene can be detected in one sensor. So there is a lot of calculation need to be done by my student to make sure the signal can be separated accordingly to the type of VOC. So this is normally how we do to make sure. This is optical particle counter or particulate matter sensors. So you can see there are different brands. This is from our lab that we put in a box, and then we generate smoke, and then we have a reference analyzer like green just beside the enclosure to see or to do the validation. So you can imagine how if you have a low cost sensors. However, these sensors basically are not perfectly precise reading because there are many brands. It's just like our car. You have Proton, you have Mercedes, you have very type of car brands, but the performance are different. Maybe the Mercedes is much more better. Maybe like Dato' Halimah use Mercedes or Puan Nurul use Mercedes. I'm use Pro 2 Asia are different, but it's still a car and can be drive to balik kampung and so on. But for sensors, even though you have many brands, but the sensitivity are different. For example, I cannot do my Pro 2 behave like Mercedes belong to Puan Nurul, kan? So I need to have a proper method. You cannot do at car, but you can do for sensors. So we use machine learning. I will talk you about how we use machine learning to make sure the Pro 2 can behave like Mercedes. Okay. Because these sensors basically in our climate in Malaysia, in our case, our experience for the past many years, the humidity and temperature is one of our threat. The signal will be disturbed when you have high humidity and so on. So this is why basically we need to do the calibrations so that our data is accurate. So basically, this is a layman concept. How it's just like you can imagine that the sensors is a baby, is a toddler or baby, and then machine learning is the parent. So basically, what we do, our children will do, right? If we throw rubbish outside the dustbin, our children also will follow, right? So this is basically how the machine learning, we try to train the sensors to behave like reference analyzer. So machine learning is a knowledge, and reference analyzer are the parents, and sensors are the toddler. So how we can apply machine learning by using the most important to do the calibration, you need to have reference analyzer beside your sensors so that you can validate. You can use machine learning so that the sensors will adopt the whatever machine learning that we are using, because machine learning has different models. So you can Google what type of model under machine learning, but for our we use fit regression function so that the sensors from the data from sensors can be the bias from the local sensors can be neglected by using machine learning so that it behave as according to the reference analyzer. So this is the concept. It's very technical, but basically how we do is we just place our data inside the machine learning and train the machine. The machine learning will train the data from sensors to neglect all the bias so that it represent as reference analyzers data. So this is basically what the special tools that we use for sensors calibration. You cannot use machine learning to do gas chromatography calibration, or your car. You can imagine also calibration is just like you service your car to make sure your tire align, you can drive smooth. So this is basically what calibration can be important for sensors technology. So machine learning, when I said model, it's just algorithm. It's just a bunch of mathematical formula. For example, like when you purchase the AlphaSense sensor, you will get a technical sheet where contain algorithm model that used to calibrate carbon monoxide sensor, for example. So you can, but you cannot use Excel to run this model. You need like platform like MATLAB. Like my student use MATLAB to apply this machine learning to reduce the bias of the sensor. Because when you purchase sensors, sometimes the sensors can overestimate the result. So how you can neglect the bias, the noise, and so on, so that it can be trained to make sure it precise. And by leveraging the patterns it has learned using the model, so now it can identify the errors bar, the error bars or standard deviation errors between low cost sensors and the reference analyzers. So this machine learning basically to make an adjustment of the sensors, of the sensor reading, as I said now, to neglect all the bias or inaccuracies caused by humidity or temperature, and also any type of drift signal. So ultimately, machine learning helps improve our calibration so far. So expanding our knowledge by using different type of machine learning, because machine learning has many type of models, and now people using the term of deep learning. So this kind of evolution of machine learning that we are currently still doing a lot of studies and research to help our sensors can be as precise as a reference analyzer. Okay, so this is just
sorry to interrupt for a while, Dr. Shahrul.
Yeah.
It's about 5 minutes to 1.
Yeah, I almost
have another 10 minutes.
Yeah, okay.
Okay.
Thank you, Sharon. Yeah. So this is just how we do the correction bias by using machine learning. So you can see different sensors model. So this is how we correlate with reference analyzer. So this is how where we check the sensitivity. Here we span with zero concentration of gas, like zero air, and then you can see the signal up because we span with high concentration. In this case is ozone, and then we can see this. We can see from this testing that AlphaSense has a good response towards different type of concentration. You can imagine if you put sensors in real field, suddenly they are open burning, reach the sensors area, and then if you have not sensitive gas sensors, it will not detect as fast as it can. So this is why sensitivity lab experiment is very important. So it is the same experiment we conducted for carbon monoxide from zero concentration to up high concentration and to low concentration for nitrogen dioxide. So this is basically how we do the calibration, so that you all can see the picture. You can imagine. So where we have zero air to produce zero clean air, and once reach the reference analyzer should reach zero concentration of gas, and our sensors also need to measure zero concentration gas. So if the sensors detected higher, so this is where the machine learning is used to train the sensors not to pick up that concentration. So other than that, we also span with gas standard, SO2, any kind of parameters that we want. So this is how we do the calibration in our laboratories. So this is after that we do the correlation with reference analyzer. It seems like working. Correlated well for all parameters. So this is we do the calibration, validation at DOE station at Miri, Sarawak. So this is how we do the co-location between sensors and reference analyzer by DOE. Thank you so much, Puan Nolin. This is during Puan Nolin era where we do the collaboration. So this is we can see that the black one is a airbox and the red one is reference analyzer. Is quite pick up almost similar pattern. So we have a power issue for the sensors. That's why, but we can see the NO2 is also quite almost in the same range. So this is where we do the haze studies in 2019. So this is, I just want to share how we after calibration, validation. So we deploy at various type of different areas, such as inside a train. We collaborate with Prasarana. So this is just the graph of in LRT, in bus, how it look like of PM 2.5. We also collaborate with hospital. This is case study for MBPJ, have been used for more than 3 years now, almost 3 years now, sorry. And so this is where the machine learning can do nice plot and so on. So this is where we have a team member that can help to make valuable of our data. So we also have a funded project by CRES for drone. So this is where we measure different area using drone. So I think this is if I'm not mistaken, this is CO2. This is for TVOC. So this is machine learning adaptation that we can use. So for conclusion, I think it can be a promising technology, can assist, but I just want to emphasize yet. These sensors cannot be replaced reference analyzer. It can be a tools that can support as long we emphasize the calibration and validation process. So this is important. And low cost sensors may not provide the same level of accuracy as reference analyzer. So that's why we need to have a more deeper understanding using more models from machine learning or deep learning, so that it can be reached same level. At the moment, we use just for individuals, communities, and researcher, and we want to make sure that it can be effective in the future. I think this collaboration in the future can be strengthened so that we can help each other. We can engage with DOE, for example, to deploy at remote area and so on. So this so far is our publication, so that we want to make sure the data is precise with comparable with reference analyzer. So this is back in 2019. We also now working with we have our new technology called AquaSense to monitor. It's just like airbox, but for water. This is we also assemble with noise meter, so that we can see how the correlation between noise and air pollutants. We are also assembled with portable weather station, so that we can know much deeper what actually happened at that particular area. We engage with school under UNICEF project. So this is the impact measurement so far. So recently we collaborate with Malaysian Airport Berhad. After COVID-19, many agencies like to know the IAQ level in their premise. So this is one good opportunity. I think this is. I just want to thank our sponsorship. And then I think that's all. Just want to share, collaborate with Datuk Lee Chong Wei, not in a badminton, but we collaborate in terms of air purifier and air quality sensors. Potential, I don't know, commercialize in the future. Thank you.
Dr. Shahrul, would you like to share a video? If most of you can stay back to have just the video.
Yeah. Okay. I will share. So I just want to share with you our product called Airborne Sand. So I will play now. Okay, I think that's all, Ms. Sharon. Thank you.
Okay. All right. Thank you for the lovely presentation. We do have one question from one of the participants. Hi, Dr. Shahrul. Is it possible for machine learning to predict the air quality when the sensor is down? Is it able to do it?
Yeah, thank you. Good question. Basically, when we talk about machine learning to do the prediction, we need to have a long set of data. So if the sensors were down, so we cannot do the prediction. But we can only do the prediction, for example, if we have a data now and we use 3 days back data, and if there is no change in terms of temperature and humidity, we can do the prediction. We can do the prediction what will be happen in next 3 days. So basically, I hope that answer your question.
Okay, yeah, I hope it does. Before we end, can we just switch on our cameras, those of you who can, and we'll just take a quick photo of this session. We would really appreciate it. Thank you. Mr. Ng, does that answer your question? Did Dr. Shahrul answer your question? Thumbs up?
Yes, he did. Thank you.
Okay. Thank you. No more questions, huh? Can voice it also. Those who can. Okay, we have to take like maybe at least 2 screens because there's more than 20. Wait, 5, 10, 15.
Rindunya Puan Olin.
Yeah, we might take the next page. Wow, Dato', Puan Olin. Yeah, everybody in the house, all the good people.
Dato' Alimah, Puan Olin.
Thank you for switching on your camera. Okay, Jim, you ready? Yeah. 1, 2, 3. Can?
Now next page.
Yeah, next page. Okay, 1, 2, 3.
It's done.
Okay, can. So thank you for joining us. We hope that you enjoyed the session and learned some useful information. Dr. Shahrul is very popular on LinkedIn. You can find him there. And yeah, you're welcome. We enjoyed your company and we hope you enjoyed our company. Just a short note, we do have some trainings coming up to serve you all as environmental professionals. It's on environmental noise and environmental vibration. And then if you join this one, or if you joined last year's Dr. Hui's training, then you would be able to join the noise barrier design, which will be held. The noise will be on the 25th of July, the vibration on the 24th of August, and the noise barrier design on the 21st of September. Yeah, so all these will be also approved by HRDC. I've already approved the noise and vibration. I'm just clearing the noise barrier design, and it will all be held online so that wherever you are, you can join us. Last year's response was very good. And because some people missed it, we are bringing it back in. So I hope we will be able to see you and you can catch Dr. Hui, who does the LRT projects and things like that. Cannot get Prof. Salman, unfortunately. So he was part of Prof. Salman's team. So you can also buzz me, but I'll share the brochures with you when it's ready. Okay, so time for lunch. Those of you who haven't makan, we hope you will grab something to eat, okay? And thank you again, and we hope to see you again soon. Bye. Thank you.
Bye. Thank
Have a
you.
nice
Thank
day
you.
and
Prof.
Thank you.
Thank you,
Bye.
everyone.
Nice to see you.
Bye.
Thank you.
All
Bye,
the best,
Dato'.
doctor.
Bye, Yusri. Thank you.
Bye, Dato'. Bye.
Thank you, Dr. Shahrul.